sure.
Okay, so this is, like I mentioned in the group, the second last argument. The only argument that we have left would be is the resurrection, and then we are going to have maybe a couple of short interaction sessions, like maybe casual one offline session, casual, and then maybe let me see if I can get our global director to take one practical session for us. So that is just about it. We are coming to the very last end of the training program. And today we're looking at part two of the fine tuning argument. So in the last time when we came together, we looked at what do we mean by the term fine tuning, right? We were talking about how there are these constants and quantities, these mathematical constants and quantities within the universe that are kept at a very specific figure that will allow life to exist. Yeah, what do we mean by life? We said we are not talking about highly complex orders of life like our bodies are. Our bodies are very complex, highly adaptive, and as such. And we're talking about the very basic form of life, like even maybe at the microbial level, with the basic ability to take food, energy, adapt, reproduce in the simplest sense. So we said that the universe is adjusted to a very specific level so that this very basic form of life can exist. And uh, and then we looked at some of the response people have said about the puddle analogy, and we said we are talking not about universes with different laws of nature. We're talking about the same laws of nature, but what if the values and the quantities and the numbers within those laws were changed? What if gravity was more powerful? We're not talking about whether the law of gravity is completely rewritten. We're talking about, given the law of gravity in the equation that we know, what if the value of the gravitational constant or the power of that gravity that we represent as a number, what if that was stronger or weaker? What would that mean for the universe? What would it mean if the ratio of electrons and protons were different, the ratio of the mass of electrons and protons were different, and so on and so forth? So that is what we covered. We covered the groundwork for that. Today we will look at what the fine-tuning argument is in its proper form, in its exact structure. We will look at what are the different explanations for this fine-tuning in the universe, and then we will see at the very end what are the objections people bring about when we say the universe is designed. So the fine-tuning argument, it follows the same structure we saw with the moral argument and the Kalam cosmological argument. You have two statements, and then it leads to a conclusion. Forgive the formatting issue. So the same format. The format is very same. You have P1, P2, premise one, premise two. Basically, two statements. If both the statements are true, and if the logic that is connecting both the statements is valid, if you are doing no logical fallacy or anything of that sort, if your logic is valid, then the conclusion must be true. So the fine tuning of the universe is due to either physical necessity, chance, or design. That is premise one. Premise two says it is not due to physical necessity or chance. So the conclusion, therefore, it is due to design. So this is the whole point of the argument. And the fine tune, when we use the term fine tuning, we're not implying design. We're not injecting design into the argument before we prove it. What we simply mean is that the quantities and the values and the constants we find in the universe are adjusted, it seems, or kept at a very specific amount, a specific gap that allows for life to exist. That could be because the universe could not have been any other way. It could have only been in this way as it is. Therefore, these values exist, or we were completely lucky that we got these values, or someone designed it. Thus, those are the three explanations that we can look at. We see that these constants and values and quantities are this very narrow gap that allows even for the most basic form of life to ever exist. And we ask, okay, what could be the explanation that we find this fine tuning in the universe? It could be physical necessity. Again, it means that the universe could not have been in any other form. This is the only way the universe could exist. If the universe existed, if the universe were to exist, this is the only way it could exist, no other form. So, is that the explanation? Or is it that we were just sheer lucky to have this universe with these values? Or is the explanation that the universe was designed? So, these three explanations exhaust all possibilities. There is no fourth explanation that we can conjure up. There is no fourth explanation that we can bring in. These three is the limit. There is no fourth option out there. So what we're going to do is we're going to eliminate the explanations that don't fit in, that don't make sense, that cannot be defended, and we will eventually hopefully come down to one explanation that seems to make best sense of the data. So this is the core of the argument, the structure. Like I said, it's a deductive argument. And for this argument to be successful, the statements have to be true and their logic must be valid. Now, premise two, when we say that the fine tuning of the universe is not due to physical necessity or chance, it is this premise that people are going to contend the most. Right? Because there will be scientists who say, no, 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 the universe had to be this way. Or there will be scientists who would come and say, well, we were just lucky to have this universe. There is no specific reason per se. We just happen to have this universe. And it would be this premise that most people would be objecting to. So given that we've seen the outline of what the argument is, we will look at what are the explanations. Well, the first explanation is, and Abel, good to see you to join us. Abel, can you hear us? Abel, am I audible?
Loud and clear.
Yeah, great. Abel, it's great of you to join us. So Abel and I have been in touch recently. Abel is studying in Jaipur, and Abel is interested into evangelism, youth evangelism, and has a liking for apologetics. So I told him to join our series. So Abel has been following up with the previous content. So Abel, we were just looking at part two, the final part of the fine-tuning argument. We were just giving an overview of what the form of the argument is. This is the core form of the argument. This is the structure, and we were saying that for the argument to be successful, these statements, premise one and premise two, P1 and P2 must be true, and the logic that connects these statements must be valid. If that is the case, then the conclusion will follow. What is the conclusion? That the fine tuning of the universe, the complexity of the universe, the specification of the universe is due to design, not by chance, not by any sort of necessary situation, but it is purely by design. So what are the explanations? This is where it gets, this is the core of the argument. One explanation is that physical necessity, which means that the universe had to be this way. It is physically necessary that the universe must have the value of the gravitational constant as is, the ratio of the mass of protons and electrons as is, and so on and so forth. Right? Which means that the universe could not have been any other way. This is the only way a universe could exist, and therefore it exists. So what it says is that a life permitting universe, our universe permits life to exist. So it is a life permitting universe. So the statement is basically that a life permitting universe is a must. If a universe were to exist, then this universe must exist. There's no further explanation needed. What it also says indirectly is that a life prohibiting universe, a universe that does not allow life to exist, is an impossibility that just cannot exist by physical conditions. So the argument says that if a universe were to exist, this universe must by all physical necessity exist. There is no other universe that we could ever get or ever think of getting. The issue with this statement is that there is a critical lack of proof to substantiate the statement to say that this is the only universe that could ever exist. And this is basically the core reason why we can't say that physical necessity is a good explanation, that this universe had to be this way. In modern cosmology, there is an attempt by scientists to bring up what is known as a theory of everything. And what this theory of everything tries to do is that it is trying to, simply put, bring a unified theory to explain everything that we know within the universe. And its direct and specific attempt is to look at the forces of nature: gravitational force, strong nuclear force, weak nuclear force, and electromagnetic force. What it tries to do is that it is looking at these four forces and trying to unify them under one theory to explain why gravity is the way it is, why is strong nuclear force the way it is. So that is the aim of the theory of everything. Now, the theory of everything has different candidates under it, like different sub theories that have the same agenda, but then try to do better than other theories. And this most promising candidate that cosmologists put forward is called string theory or superstring theory or M theory. And I'm not going to get into the details of it, but you will see this in pop culture, in shows like Big Bang Theory, and as such, where people reference the string theory, because it is said that the string theory will help us to explain why the universe is the way it is at the most fundamental levels. When you talk about atoms and protons and molecules and all of that, when we're talking about the fundamental structure of the universe, there is a question: why is it the way it is? So it is assumed, and it is hoped, that string theory will help us to explain why the universe is the way it is. Now, can string theory, the best candidate that is aimed at unifying everything that we know about the universe, that is aimed at helping us understand why the forces of nature are the way they are, which is what we were talking about with the fine tuning argument, the specificity in the force of nature. Can it help us to give us some answer? Well, here's what Stephen Hawking says. He says that string theory cannot predict the dimensions of space, time, and other parameters, and so on and so forth. So he says, to come back to the question, does string theory predict the state of the universe? This is what we are asking, right? And he says the answer is that it does not. It allows a vast landscape of possible universes in which we occupy an anthropomorphically permanent location. In a sense, Stephen Hawking says that the string theory does not tell us why this universe exists, or it does not predict that this is the only universe it could exist. All that string theory, the best candidate at explaining and unifying all the forces of nature, tells us is that there is this huge landscape of universes, and we just happen to be one among it. That's it. Now, how big is this landscape that Stephen Hawking is talking about? What is the size of this landscape? The size of the landscape is 10 to the power 500 possible universes. Now, in the last session, we talked about using this mathematical figure, and that's a formatting error. In the last episode, we talked about using this mathematical point of 10 to the power 1, 10 to the power 2, how big the values are. 10 to the power 500 means the number 1 followed by 500 zeros. The number 1 followed by 4 zeros is 10,000. The number 1 followed by 6 zeros is 1 lakh. Okay, 1 lakh universes is a huge number of universes, right? 7 billion is a huge number. But imagine 1 followed by 500 zeros. That is an astonishingly large number. What Stephen Hawking says is that string theory tells us that there is about 10 to the power 500 universes out there that it can predict, that it can allow for the existence of. And these universes are different universes. One is different from each other, but they all have the same laws of nature. Like we discussed in the fine tuning, same laws of nature apply across all the universes. But they all are different in one way or the other. Gravity may be powerful in one, gravity may be weaker in one, slight variations, so on and so forth, in its most nuances, and so on and so forth. So the best candidate at trying to explain why gravitational constant is as powerful as it is, or similar questions, only lets us this, that there is a possibility of 10 to the power 500 different universe, and we just happen to be one. So even the best candidate fails to tell us that this universe is the only universe that could exist. There are 10 to the power 500 different possible universes. Now the question is, how many of them within them are life permitting? And that value is even smaller. So we're just talking about life prohibiting universes, just universes existing blindly as they are, but not allowing for life to exist. And our focus is, can there be only this universe that could not have existed otherwise, which permits life? And the answer is outrightly no. Now, that doesn't stop there, because when we were talking about fine-tuning argument, we said that there are these constants of equations, like gravitational constant. We also mentioned about this other part called arbitrary quantities. Again, what would that mean? When the universe initially came into existence, the amount of energy disequilibrium that the universe had was very low. That is an arbitrary quantity. We don't know why that was the case. We have no explanation for why that was. All we know is that was how it was. That's just it. That's all we know about what we call as the initial low entropy condition of the universe. Meaning, when the universe initially started off, the inefficiency of the universe, simply put, the inefficiency of the universe was very low. Why was it very low? We have no idea. Does string theory try to explain why that was low? It does not. This is why P.C. Davis, another reputed astrophysicist of Arizona University, he says that we still have no idea why these quantities were the way they are. That the physical universe does not have to be the way it is. It could have been otherwise. Which is the objection to the physical necessity. Physical necessity says that this universe had to be the way it is. You see the universe as is, there is no other way it could have been. Stephen Hawking looks at string theory. P.C. Davis looks at the constants and the quantities of the universe. They both say, no, this universe could have been some other way. But why is it this way? And even more, why is it a specifically life-permitting, highly improbable universe? Physical necessity cannot answer it. So what is the next explanation? The next option. Maybe it's pure chance. Maybe we are just outrightly lucky to be in this universe, right? This universe allows life in its most complex form to exist despite the massive improbability. Maybe we're just lucky. There is no explanation further than that. Now, when we talk about whether this, how improbable the luck is. People like Sabine Hofstadter, who object to the design hypothesis, they say, well, we have only one universe. How can you talk about the probability if you have only one universe, right? If you have 20 people in a class and you ask, what's the probability of me being selected? I would say it is 1 in 20. But they ask, what if you are the only person in the class? What if you are the only sample? How can we speak about any probability if you are the only person? So they ask, if this is the only universe that we know of, and this is the only universe we can ever know of, we are limited within this universe, how can we talk about the probability of a different universe with different capacity existing or not? So here is a simple diagrammatic presentation that I think, if I recall right, John Barrow pointed out. So imagine you have a white paper, and in that you put a red dot in the middle of it. Now that red dot represents our universe, a universe where life is permitted, a universe where life can exist. Now we look at the different quantities and the constants that we know within the universe, like the gravitational constant, the cosmological constant, and so on and so forth. Let's say we adjust their values ever so slightly. And then we see, okay, if this is the case, would life exist in that universe? If the answer is yes, put a red dot. If the answer is no, put a blue dot. Now, take the next constant, adjust the value, ask the same question. With this adjustment in value, will life exist in that universe? If the answer is yes, put a red dot. If the answer is no, put a blue dot. And you keep on doing this over and over until you fill up the sheet. John Barrow says, when you look at that, you will see a sea of blue with a couple of dots of red. That is how we figure out the probability of whether there are more life permitting universes or not, or how improbable, how unbelievably improbable is that this universe exists and that it is life permitting, that life can exist. And the reason I wanted to go and mention this nuance point is that this is the point that someone like Sabine Hofstadter, a trained astrophysicist, keeps on bringing up over and over and again. But in the last session also, when we looked at the improbability of life, we were looking at figures from people like okay, figures from like people like P.C. Davis, and Stephen Hawking, and Sir Roger Penrose, Nobel-winning Roger Penrose. So these are scientists who are using probability to tell us how improbable it is that our universe exists. And this presentation would help to, if you can memorize this image in your mind, it would help you to relate to a lay person what we mean by the probability and how improbable the universe is. Now, here's another way to put it across, right? Imagine you have a bag that is filled with 1 million blue balls and just one red ball. Well, the probability of picking up that one blue ball is 1 million out of 1 million one. But the probability of picking up that one red ball is 1 in 1 million one. To put it simply, 1 in 1 million. It is highly improbable. So even if someone were to come up and say, well, some universe had to exist, right? Eventually one universe or the other had to exist. It just happened to be us. True. Let's assume that some universe had to exist eventually. Maybe this universe or some other universe. But it is highly more probable that the universe that would end up existing would be a life prohibiting universe than our highly improbable life permitting universe. So this is what is known as the lottery analogy. And I didn't go into the depth because it may take us far off topic and may leave you confused. But imagine these examples also. You have one red ball in a bag of 1 million blue balls. Well, you may pick up one ball or the other. That eventually, if you put in your hand, you will get one ball. But what is the probability that that ball is going to be red compared to that is going to be blue? It is highly improbable that is going to be red, because it is one red ball in a sea of blue balls. That is the same thing with the universe. Even if we were to accept the fact that some form of the universe had to exist, it is much more probable that that universe would have been life prohibiting, a universe where there is no life, than it is our universe, a life permitting universe. This is the extent of the improbability that we have this life permitting universe. Then comes the next contender to defend the chance hypothesis. They say, okay, but what about the multiverse hypothesis? The multiverse hypothesis is that our universe is actually one of the million, zillion other universes existing out there. So we have a universe, then in that whole cluster, there are many other universes. And there are very spin-offs of these theories. These go into fiction, like with Spider-Man into the multiverse and Doctor Strange. In all of these shows and in other shows as well, the idea of a multiverse, this other reality similar to ours, parallel universe, which is also part of DC Comics. This is very much an established part of fiction. But scientists also propagate the idea saying that our universe is part of many other universes out there. And so the idea is that if you have a million, billion, zillion, trillion universes out there, then eventually, out of all these n number of universes, one universe would eventually end up being our universe, right? If you keep on churning out universes over and over and over and over again, and there is no limitation to it, eventually you will come to a point where you get a universe that is our universe. What do we mean by our universe? A universe where life in this complexity can exist. A universe that is fine-tuned like ours. So that is why people would bring up the multiverse hypothesis and say, well, it explains why our universe is fine-tuned. It's not because someone came and did something, or it is not because this universe had to exist. No, it is just that there are a zillion, trillion, billion universes out there. All of them are not allowing life. And because there are so many universes, one of the universe turned out to be our universe where life exists. But the question is there any scientific backing to this hypothesis? So, brilliant astrophysicist and cosmologist Alexander Vilenkin. It's a very popular name when we talk about Kalam argument as such, because the Bode-Guth-Vilenkin theorem showed us that the universe, that the Big Bang is basically true. So, Alexander Vilenkin is one of the main champions of this many world hypothesis or multiverse hypothesis. And he outrightly says that if we know that scalar fields, these things that he calls scalar fields exist, then that is a great piece of evidence showing us that the multiverse is true. So, so how do we know the multiverse is true? If we at some point detect scalar fields, as Dr. Vilenkin calls it, then we know that the multiverse is true, right? And this is a pivotal piece of evidence. So even if someone were to come and talk to you about the multiverse hypothesis out of the blue, you can always keep this information in your mind. The existence of scalar fields is important for us to decide and come to the conclusion whether multiverse is true or not. What does Alexander Vilenkin himself say? Another important question is whether or not such scalar fields really exist in nature. Unfortunately, we do not know. There is no direct evidence for their existence. So, the person who champions, who pushes forward the many universe, multiverse hypothesis, comes up and says the most pivotal piece of evidence that we need to say that multiverses exist does not exist. We don't have any direct evidence to say that these fields exist. So therefore, the multiverse hypothesis also fails to account for it. So we saw initially when we looked at the explanation of physical necessity, when we asked, could this universe be the only universe that exists? Is this the only way a universe could exist? We saw from Stephen Hawking and P.C. Davis talking about string theory and so on and so forth, how there could be 10 to the power 500 different universes, one followed by 500 zeros. That many number of different universes could exist. So we cannot say that this is the only universe that could exist. So that is removed. Then came up the objection, maybe this is just pure chance, right? The problem is super high that our universe is one among many. The multiverse hypothesis cannot stand up to scientific scrutiny. So you will come across the multiverse hypothesis if ever you were to engage in a dialogue about the meaning of the universe or why the universe is the way it is, because it is part and parcel of fiction. So keeping this scalar field lack in your mind, and especially the name Alexander Vilenkin, uh, brilliant. I think he even won a Nobel Prize. Brilliant cosmologist Alexander Vilenkin, who himself presents the many world hypothesis as a viable explanation, came up and said, we do not have direct evidence for the many world hypothesis or the multiverse hypothesis. And that's the end of story. And that is still the way it is. We still have no evidence for the multiverse hypothesis. It is still a part of scientific fiction where we are hoping that someday we will be open to it, but it hasn't been progressing the way scientific community would. That leaves, it is not physically necessity, it's not chance, then it has to be designed. Remember, we don't have a fourth option. There is no fourth option remaining outside out there. It has to be designed. In fact, in one of the lectures that Stephen Hawking took at the University of California, Davis, UC Davis, when he was answering this question, in his answer itself, he indirectly addressed these three. To go into it because it would be a deviation. So these are the three options. The first two fail. But when we say that the universe is the way it is because it was designed, there are going to be objections, right? A car is a very complex design, and the design of the car, human, is more complex than a car, like our anatomy, our cellular structure, so on and so forth. So they ask, we ask, who designed the designer, which is who designed the human, and the answer is God. So look at the project, look at the trajectory. A car is complex. The design of the car, the human, is even more complex. So when we ask who designed the designer, we say the answer is God. Now you may immediately see how this is going to be an objection, right? They also ask, the universe is a complex design, and so the designer, God, must be who designed God. There are two easy responses that you can keep in mind when it comes to this objection. The first one is the explanation of an explanation is not required to accept the explanation. And it sounds a bit wordy to say it that way, but here's what it means. And you can use variations of the next analogy that I'm going to give, this example. Imagine there are archaeologists who are digging up in an area and they find pots, arrows, spears, so on and so forth, right? And they're going to ask, okay, what explains the presence of these specific pots, arrows, and spears in this area? And they would say, well, it has to be civilization. So they look at the data. They don't know of any civilization that existed in that area in that time. But they conclude, well, it has to be a civilization. Now, they do not have an explanation of that explanation. What is that? They do not know which civilization that is. They don't know which duration the civilization may have, like come into that place or when they have gone out. They don't know what techniques they use. They don't know what methods they use. They don't know what materials they used. Right? They are unable to explain it further. But they know one thing: the explanation that a civilization or a group of people created these things is sufficient. They can proceed with that even if they are unable to explain it completely. Which is why we say you don't need an explanation of the explanation to accept it. And there are different variations of it. In fact, I remember I was reading a couple of months back that archaeologists were digging up a particular area and they found huge animal bones. And they noticed that there were specific cracks on the bones. So they were trying to wonder, okay, what could have caused these specific cracks? And they thought, okay, maybe the animal was trampled, and they found even more bones with similar cracks. Okay, maybe the animal was trampled, maybe it had some sort of disease that caused these cracks in the bones, or maybe some animals, came and these were dead bodies, and the animals came and tried to crack open the bones and so on and so forth. And the final option was, okay, maybe human. There was this one specific group of humans who we didn't know who existed here, who were using the bones for the bone marrow or something like that sort. And what they did was they looked at those cracks and they tried to see, well, what form of crack does it resemble? Does it look like a crack that an animal could bring upon by breaking it, like stepping on it? Does it look like something a bird could poke into it and make a crack? Does it look like something as a result of a bone disease? Or does it look like something that humans that we know in that time used to crack open bones? And the conclusion was these cracks were very similar to Neanderthals and others. The crack that they would cause when they would take an animal bone, they would use specific rocks and crack into the bone to take the bone marrow and use the bones for other purposes and as such. So they came to the conclusion in this part of Northern America, during this duration, there was a group of species that were as advanced as the Neanderthals who were able to do the same thing that the Neanderthals were able to do. They don't know which subsection of the tree of species they came from. They don't know which group that is or how they managed to do it. The only thing that they know is that this came as a result of a highly intelligent species. And they were like, okay, maybe the Neanderthals, traveled from Africa or the European areas to North America much earlier than we knew, or maybe it was the hominids and so on and so forth. Their conclusion was there was a subsection of human or subhuman, whatever we call it, species that traveled to that area much before than our earliest estimates allowed us to. But do they know which exact subsection that is? No. But you can proceed with that explanation. Why? Because it makes sense of the data. In the same way, when we say that the explanation of the fine tuning of the universe is design, when we talk about human design or whatever form of design, if we say that a designer is the best explanation of the data at hand, we are not burdened, we are not required to explain everything about who or what this designer is, or if this designer even had a designer, and so on and so forth, to accept that there was a design, that there is a designer. Now the issue is, and this is an interesting point to note, when an atheist comes up to you and asks, who designed the designer? Let's say I say yes, the universe was designed by God and God has a designer. The question is, what does the atheist do then? Because for me, my starting point is that the universe has a designer. To the atheist, the universe does not have any design. So if I accept, you're right, God has a designer. What does the atheist do? Does he say that he wants to push the question back? Because he's already lost his ground. What was his ground? There is no designer to the universe. But by asking the question, he has considered that the universe has a designer, which is the point that he didn't want to do in the first place. Now, if he pushes the line backwards, we can keep going back basically infinitely backwards, right? Who designed the designers? Who designed the designer? You can keep going on and on and on and on and on. Where would you stop? At what reasoning would the atheist or the materialist give to say that at this point the design chain stops? There is no reason to say at this point the design chain stops. There is no reason to say that the second designer of the universe is the final designer, or that the thousandth designer of the universe is the final designer. For me as a theist, for me there is specific ground. When I talk about what the nature of the designer is, we looked at the Kalam when we said the cause of the universe is uncaused, first cause, omnipotent, omniscient, all of that stuff. We have all of these properties to tell us that the designer of the universe doesn't need a designer. It is the ultimate designer, the uncaused cause. Does not need a creator, and so on and so forth. I have reasons to justify why I am stopping that line there. To an atheist who asks, who designed the designer? First, he will lose his immediate ground when he accepts that the universe has a design. So he's lost the battle immediately. And he doesn't have any reasoning to go back in line and put a full stop at any point. Why not you stop earlier? Why not stop later? He has got no point. So the point someone brings up this who designed a designer, keep this first point in mind. To accept an explanation, you do not need an explanation of that. You can use these examples to bring out the point. Because when I first read it, I couldn't understand it completely. When I looked at these examples and how it was done in scientific methodology, it made proper sense to me. So keep this example in mind. Also, you can ask the same question. What are you trying to conceive? Does the atheists already lose the battle when they accept that the universe had a designer, which is what they don't want to do in the first place? And where do you stop the line of this designer that can keep on going backwards? Why stop where you're stopping? That is the question to the atheist. The second key response to this point is God as complex as the universe? Now, God is a spirit and an unembodied mind. What do we mean by that? A mind without a body. We are minds with a body. There is a mind-body unity. It's called a substance dualism. Two substances in unity, a mind and a body. But God doesn't have a body. He is not made of parts like we are. I have arms and legs and arteries and veins and all of these complex things working together in that structure. They are put together. But God is a spirit, a mind without a body. And a mind is quite simple. It isn't made up of these parts. And what is also interesting is that I am not a necessary thing, right? I could have born with 5 legs. I could have born with 11 fingers. I could have been born with an abnormality in my heart, like an extra chamber and so on and so forth. And the same thing applies to all humans. We could all have been born or all have been formed in one way that is different from this way. So we aren't necessarily existing. Like, this is not the only way we could exist. We could exist with different deformities and so on and so forth. But God is a necessary being. He is who he is. Like when he revealed himself to Moses, he said, I am who I am. There is none like him, there is none beside him. He is as unique as he is. He is a necessary being. It is when we talk about humans who could have been born this way or that way, where we get into complexities of different formations and combinations of existence. But God has necessary properties. He must necessarily be omnipotent. He must necessarily be omniscient. He must necessarily be omnipresent. Why? Because he is the greatest maximal being, the being that we could conceive the greatest of. And he has all of these properties as necessary form. That is as simple as you can get. It is with humans that you can go with different combinations and complications, and you get a very complexly put together structure. God is simple, a spirit, a mind without a body. And even though God's ideas, the universe, for example, or my body or my anatomy may be complex, that doesn't mean that God is complex. So when someone comes up and says the universe is complex, so and if it has a designer, then God should also be complex, and therefore he should have a designer. Our immediate question is, in what way is God complex to you? What is your criteria of comparison? You are comparing with a thing, a universe that is put together of different components, space, time, reality, space, time, continuum, different dimensions, and so on and so forth. That could have been existing in other ways, which adds more complexity to its existence. You are comparing that with a simple mind, a mind without a body, a spirit that is not made up of parts, that is existing as who he is eternally, as with necessity. He could not be any other way. He is who he is. So, in what way is God complex when you compare with a universe? Now, God is awe-inspiring. And when we think about who God is, our minds are blown. We're going, wow, what an amazing God. That doesn't mean that therefore he is complex. Even though we may say the same feelings of wow and awe-inspiring at the universe, it doesn't mean that therefore God is complex. So if the question is that God is complex, it is up to the person who puts it forward to show why or in what sense or how exactly God is complex. Now, to recap it, we looked at the form of the fine-tuning argument. Premise 1, the fine-tuning of the universe is either due to physical necessity, chance, or design. Premise 2 said it is not due to physical necessity or chance. Conclusion, therefore, it is due to design. And we looked at how physical necessity fails to explain the structure of the universe. String theory says that there are 10 to the power 500 different possible universes. So this universe is not the only universe that could have ever existed. There could have been another form of universe. Life may not have existed there, but it could have been some other universe that did not allow life to exist. So physical necessity fails. We looked at chance. We said how multiverse, the best candidate that is put forward, does not have evidence to back itself up. So much so that it fails to account for the way the universe it is. So chance gets pushed out. And when we look at the probability of all the criteria and fine-tuning properties coming together, we see how highly improbable it is that this universe could be the way it is. It's much easier to believe that you could pick every lotto that you ever take and win in your life than to assume that this universe could simply be here by pure luck. Then we looked at the objection. Who designed the designer? We said explanations don't need explanations. You can accept an explanation or a theory if it makes sense of the data. Same with the designer. And we also said God is not complex like the universe or a human body. He is simple. He is a mind without a body, a spirit. So therefore, you can't equate the complexity of the universe with who God is, and that leads us to the end of the argument fine-tuning argument section. So I'm just going to go and stop the recording.